Hello students, today in this lecture we will discuss about compound indexing. As we have discussed in our previous lecture, direct indexing and simple or plain indexing. So now in this lecture we will discuss how this compound indexing is different than normal direct or simple indexing method. So now we will understand this compound indexing method by considering certain number of steps and similarly with an example. So starting this compound indexing method, suppose the question is like that: explain the method to enable 69 division on the workpiece using indexing. So if the question is like that, first of all you need to make sure which indexing method you will use. So for this method, first let us understand if direct indexing method can be used. As we have discussed its limitation, it is used only up to 24 number of holes. So this direct indexing method cannot be used. Similarly, second one is in simple or plain indexing. As we know, the gearing ratio is 40:1. That means 40 revolution result into one complete revolution of the workpiece. So that method is limited to 14 number of division. That means 40 division on the workpiece can be obtained by using that simple or plain indexing method. So over here the division given that are 69. So more than 40 divisions, that means compound indexing method or differential indexing method that needs to be used. And how differential indexing method can be used, that we will also discuss in our further lectures. So now let us start with, if question is asked to obtain 69 division on the workpiece, then the steps to be followed that we are discussing over here. So first of all, if 69 divisions are asked or any number of divisions are asked, the first step that is to consider the factor of given number. That means suppose the 69 divisions are given. So what are the factor of 69? So the factor are 23 into 2, because 23 threes will give you 69. So you must need to have basic knowledge of factoring any number. So the first step that is to consider factor of a given number. Now the second step, for this second step you must need to have the basic knowledge of Brown and Sharpe indexing plate, because in compound indexing method also universal dividing head will be used, and in universal dividing head, as we know, Brown and Sharpe indexing plate will be used. So we must need to know how many number of holes are available on that Brown and Sharpe indexing plate. So let us have a look at this particular point. In Brown and Sharpe indexing plate, 23 or 3, this number of holes are available. So if we recall, on plate number 2 of Brown and Sharpe indexing plate, 23 number of holes are available. But that 3 number of holes are available? No, 3 number of holes are not available. So from this factor, consider that number which are available on Brown and Sharpe indexing plate. So our second step is to choose the indexing plate which are available. So over here 23 number of indexing plate is available. So as a reference point of view, always consider the one plate which is available and the next number which is available after that particular number. That means over here the 23 number of holes plate is available, and after that 25 is not indicated and that plate 2. So after 23 the next number of holes available, that are the 27. So over here select two plates or select plate that has holes 23 and 27. So which is nothing but the Brown and Sharpe indexing plate having set 2. So this is our step 2. Now next step is take the difference between the selected holes. That means, as we can see in step 2, we have selected plates having holes 23 and 27. So the difference between these two holes, that is 27 minus 23, that is equal to 4. So to take the difference between the selected holes, that is our step 3. Now the fourth, that is the basic step, that is to consider the gearing ratio. And as for compound indexing, universal dividing head is used, and in the case of universal dividing head, we know that the gearing ratio available for worm and worm wheel, that is the 40:1. So just simply write this step, the gearing ratio available is 40:1. Now the next step is, now use the main formula that is given over here, and this formula will help you to calculate or to solve this question in further steps. So the formula is division required multiplied by difference of holes on the plates divided by 40, and 40, that is nothing but the gearing ratio. 40 multiplied by first circle hole multiplied by second circle hole. So now you need to memorize this formula to calculate the examples of compound indexing, or to write the theory of this compound indexing also. So now compare it with our example. Let us write from this formula. As you can see, first, what are the divisions required? The first step, that is to write the divisions required, and for us the division required that are 69. So first step is 69 divisions are required multiplied by difference of holes on the plates. So the difference that we have found in step 3, that is 4. So write in multiplication 4 divided by, in denominator, first write 40, which is gearing ratio, multiplied by first circle hole. So what are the first circle holes available? So that is 23 number of holes available, and the second selected circle hole, that is 27. So that is 27. So write all the details that are available to us. Now just solve this basic numerator and denominator, and never use the point or digital form in which you have points are also available. Just use the fraction form for any compound and differential indexing, or if I can say for indexing methods of this milling chapter, always use the fraction forms. So by just solving this equation, you will get fraction form, that is 1 divided by 90. And as in numerator you are getting 1, that means the method or the steps that you are following, that are the correct. But if in such case you are not getting 1 in numerator, or you are getting any other value than 1, that means you have made certain mistake in above steps. So as a verification point of view, you can keep it in mind that in numerator you must need to obtain value 1. Other than this value may give you the details that you have made certain mistakes in above steps. So over here we have obtained one value after using this formula, that is 1 divided by 90, and the value available in denominator will be helpful for further steps. So moving towards our next step, and for the next step use the simple formula. Again you need to memorize this formula to solve the example of this compound indexing. So the formula is, use the denominator of step 5 result, and as you can see over here in step 5 the denominator obtained, that is 90, and that is divided by first whole circle, and first whole circle, that is nothing but the 23, minus over here the sign is minus, never change this sign, this is the standard way. So minus denominator of step 5 result, again denominator of step 5 result, that is nothing but the 90, divided by the second whole circle, and this second whole circle, that is nothing but the 27. So we have all the values available. So just our next step is, just write the given values. So first 90 divided by first whole circle, that is 23, minus again 90 divided by second whole circle, that is 27. Now again solving this particular form, writing this content, try to write this detail in partial fraction form. So to get this, after converting it into partial fraction form, we will get as 3 and 21 divided by 23 minus 3 and 9 divided by 27. So if you simply solve this form, you will get this above step only. That means if you solve this 3 and 21 divided by 23, you will get 90 divided by 23. How? So to solve this, you just need to multiply 23 into 3, that is 69, and add the numerator value, that is 21. That means 23 into 3, that is 69, plus 21 divided by 23, that will give you 90 divided by 23. And similarly for this second case also you can obtain 90 divided by 27, but always try to convert these above details in below given form, because this will help us to interpret the result of this compound indexing method. So further, converting this detail, as you can see from above step, we have just removed the value 3 and 3. So the reason behind removing these values, that is nothing but, if we say this 3 shows the rotation, 3 times rotation in clockwise direction, then this minus 3 shows the rotation in anti-clockwise direction. That means if you rotate one thing in clockwise direction, if you give 3 complete rotation, then it will rotate 3 times, and if you further give it rotation 3 times in anti-clockwise direction, it will only and only come to its initial position. So due to that reason, we have just removed that value 3, and at the end you will get the value such as 21 divided by 23 minus 9 divided by 27. So this final result is much more important to us, because this interpretation of this value give us the complete 69 divisions that are required on the workpiece. So first of all, let us interpret this particular result and what is the actual meaning of these values. So over here, first 21 divided by 23, this actual value interprets that on 23 hole indexing plate, one must need to rotate crank pin through 21 holes. Means on 23 holes indexing plate, from initial position rotate up to 21 holes available on the indexing plate. And over here, if the direction of rotation, that is the clockwise, then as you can see over here minus sign is given. So if in first step one has rotated in clockwise direction, then for the second step anti-clockwise rotation is required. So for the another second step, what will be the interpretation? So interpretation is like that: on 27 holes indexing plate, rotate crank pin through 9 holes in anti-clockwise direction, because the negative sign is given. So for the same indexing plate, first rotate 21 holes on 23 hole indexing plate in clockwise direction, and then again shift the crank pin to the 27 hole circle on the indexing plate, and then rotate through 9 holes on the 27 holes indexing plate. This rotation will give one division or one rotation required for the one actual division for this particular workpiece, and to generate these 69 divisions. So this actual rotation needs to be repeated 69 times, which will give actual equal 69 divisions on the workpiece, and after performing machining operation, after each and every rotation, one can obtain 69 number of teeth on the workpiece at equal distance. So this is nothing but the compound indexing method to generate gear teeth on milling machine. So for you to solve any number of examples that may be asked in the examination, you must need to follow the steps given over here. So all these steps needs to be followed, and at the end try to convert the form given over here, and the interpretation for any of the examples will remain the same. So to understand these in many more ways, let us take another example for this compound indexing, and as I am giving you this example, try to solve by this your side, and after that compare over here. So now let us take an example to obtain 51 division on the workpiece. So first of all, for this select the proper indexing method, and as we now know the limitation of first two methods, you can understand this. For this one can use compound indexing or differential indexing method, but over here as we are studying compound indexing method, we will use compound indexing. So for compound indexing, to generate 51 divisions, follow the same steps that we have discussed in our previous example, and the steps are shown over here, and just using these steps try to solve by your side and compare it whatever the solution I am giving over here. So the solution for this 51 division is also, first our first step is to generate the factor of given number. So the factors are 51 are factorized as 17 into 3. Now the second step, that is to select the indexing plate. So from these two number, which are the number of holes that are available on indexing plate? So as we know, 17 number of holes are available on brown and sharp indexing plate of set 1, but the 3 number of holes are not available. So select that 17 number, and after that select next number that is also available on that indexing plate. So the next number available, that is 17 and 18. Third step is to take the difference between these holes. So the difference is 1. Now our next step is to use the formula that we have discussed, and just our divisions required, that are 51, difference is 1, 40, that is the gearing ratio, first circle holes and the second circle holes, that is 17 and 18. And if you solve this in fraction form, you will get answer as 1 divided by 240. And as we know, as we have obtained the value 1 in numerator, that means the solution or the steps we have followed that are correct, and the denominator has the value 240. Now next step to be followed, that is just use another formula that is given in step 6, and you will come to know. So first is denominator of the step 5. So what is the denominator? That is 240 divided by first whole circle, that is 17, minus 240 divided by 80, that is the second equation. So just try to convert it into another form that we have discussed, and you will get another form as 14 is to 2 divided by 17 and minus 13 and 6 divided by 18. And now as you can see over here, there is a difference over here. One is 14 and another is 13. So always try to convert this first part and try to maintain similar on both sides. So we will try to convert 13 into 14, and for that we are just using simple mathematical steps, and after converting that you will get 14 and 2 divided by 17 minus 14 and minus 12 divided by 18, because we are converting this value 13 into 14 for our calculation point of view or for our easier interpretation. So now as we know, this 14 clockwise and this 14 anti-clockwise, these two can be removed, as it will lead us to our initial position only. And after further solving this, you will get next step as 14 and 2 divided by 17, and as we are getting minus sign common, it will be positive, that is plus 14 and 12 divided by 18. So just we are removing 14 as we have discussed. So you will get the final answer as 2 divided by 17 plus 12 divided by 18. So further interpretation of this result is much more important. So the interpretation is, for the first step, that is 2 divided by 17, that means on 17 holes indexing plate, crankpin needs to be rotated through 2 holes in clockwise direction. Now the interpretation for the second number, that is 12 divided by 18, that is 12 holes needs to be moved by crankpin on 18 holes indexing plate, but the direction will be, as the sign is positive, so the direction is similar to the first one only. So over here, for first and second, for both condition, direction is clockwise only. So the finally I am repeating it interpretation because this will be helpful to write in exam also, and the interpretation of final answer needs to be written in exam because it is much more important. So the final interpretation is, first rotate the crankpin through 2 holes on 17 holes indexing plate in clockwise direction. Second, move the crankpin over the 18 holes circle on this indexing plate, then rotate that crankpin on 12 holes on 18 holes circular or indexing plate and in similar, that is the clockwise direction, which will give first rotation to generate the equal division, and repeat this procedure 51 times, which will give you 51 equal division on the workpiece. And after machining operation, you can obtain 51 number of teeth on any of the workpiece using this compound indexing method. So now in this lecture we have discussed the basic steps which needs to be followed to generate the component or to generate the gear using this compound indexing method. So in our next lecture we will discuss about differential indexing method. So looking forward to see you all in our next lecture. Up to then, thank you.